Hi, so this is my exercise problem 4.62, in which I have to find out the value of this I naught by using the source transformation method. So in part A I have to find out the value of I naught, and in part B I have to verify by using the mesh current method the validity of this I naught. So in part A of this question, let us start it. So in starting this question, I can see here that basically I have three sources. One is this one, the second one is this current source, and the third one this voltage source. By deploying the source transformation method, I don't disturb the basically the element through which I have to find out the unknown quantity. So here 1.5 will remain the same, while I will transform all other sources, and similarly I have to find all the possible configurations of the available resistors. Okay, so now in order to find the configuration here, now I have three basically configurations which can be transformed into another one. First is this one, the second one is this one. Okay, so now in order to transform them, I am not basically touching this source, because I will first transform this circuit into the circuit which will contain only the voltage sources. So in order to transform it, I will see that when I will transform it, now let us again use the blue for the transformed versions. So here the same resistor will be in series with the source. Okay, so now this is the resistance of 6 ohm, and this is basically here. Okay, this is the transformed version of this portion of a circuit. Similarly, this is the voltage source, and now this one, and the untouched version of this circuit is this one. This is the 6 ohm resistor. Similarly, the other portion which will be transformed is basically this one. Okay, so now let me, so that it will be like this one. Okay, so now as the current direction is this one, so this is now plus minus here, and the value of this resistor is 5 ohm. Okay, and the other configurations here are basically this is the resistor and this is the source, and similarly this is the last resistor which is connected in parallel with my circuit. So this is 1.5 ohm, this is the 17 ohm resistor, this is plus minus 34 volts. Okay, but I have to find out the values of these two sources, and as I can see here that it is this one, and similarly this is this one. Okay, so you can easily see that this source and resistor has been transformed into the bluer version here. Similarly, this source and resistor has been transformed into the elements here. Okay, so now I have to find out the value of this voltage source and this voltage source. So similarly I can see here that V is equal to IR, the value of I in first source here is 2 multiplied by the resistor is 6, so it will be 12 volts. Okay, so that is now 12 volts. Similarly, the value of this voltage source is V is equal to IR again. The value of I here is 1 amps, and the value of resistor which is connected in parallel with this one is 5, so it would be 5 volts. So now this is the 5-volt resistor. So now here I can very easily see that the 3 resistors here connected in series with each other. Similarly, the voltage sources, these 2 voltage sources are also in series with each other. So as the positive terminal of this voltage source is connected with the negative terminal of this voltage source. So sorry, let me solve it now so you can understand it better. So now let me transform this side of a circuit. So when I will transform it, I will see that the 2 voltage sources will be connected like this one. This is plus minus 12, as these 2 are in series, so this is now plus minus 5. These 2 are in volts. Similarly, 6, 5 and 6, these 3 are also in series with each other. These 3 are in series with each other. So in order to find the equivalent of these 3 resistors, I have to add them. So by adding them, I will get a single resistor which will be equal to the 17 ohm. And similarly, the circuit here will be like this one. And similarly, we can see here that these 2 can also be added together, and after adding them, their cumulative result will be a single source which is of 17 volts. Okay, 12 plus 5 is basically 17, so I will get here 17 volts. So this is the transformed version. Similarly, by adding the circuit here, okay, so that is the 17 ohm resistor, this is the 34 volt source, and similarly the 1.5 ohm resistor is here. So this is my circuit. Similarly, now we can see here that with this voltage source, I have this 17 ohm resistor in series. Similarly, with this source, I have this 17 ohm resistor in series. So both of these circuits, or both of these branches can be transformed into the other source, which will be the current source. So now in order to transform them again, I will see here that this circuit, okay, because both are in series. Similarly, this one, these 2 can be transformed here now, and by transforming them, what I will get a current source here and same resistor, which will be of 17 ohm, and the value of this current source has to be found out. Similarly, for this source, I will find out that the current source will be denoted by this one here, and but the direction of this current source will be downward because the polarity is opposite as that of the 17 volt voltage source. Similarly, the same 17 ohm resistor here, okay, and at the end, what I will have, these 2 are basically for this one, and these 2 are for this one. Okay, so now at the end, I will have this 1.5 ohm resistor. Okay, so as we can now see that this is a single node, and across them with which these 2 voltage sources are current sources are connected. So in order to find the value of this current source, I can use here I is equal to V by R. The value of V is now 17, R is 17, so it will be 1 amps. Similar value will be used here, 1 amps, and similarly 34 divided by 17 is 2 amps. Okay, so now we have this circuit. So let me draw it clearly here. So now these 2 sources, this is source 1, this is source 2, this is resistor 1 of 17 ohm, this is another resistor of 17 ohm. So this is 1 amps here, this is downwards, okay, and the value here is 17. The value of this resistor is also 17, so it would be like this one, and at the end I will have this 1.5 ohm resistor. Okay, so now we have this circuit, and in this circuit we can see that these two are connected with a single node. Similarly, the parallel combination of these two resistors have to be found out, and I know that from the very beginning that the parallel combination of the two same resistors will be equal to the half of any of one of the resistors. So here the value of the equivalent resistance will be 8.5. so now writing them again here, these two will be combined together. Similarly, the cumulative of these two will also have to be found out. So it will be here, the cumulative, this is 2 minus 1 or 1 minus 2, 1 ampere, but it is in the direction of the dominant current source, which is this one of higher amperage. Similarly, the cumulative of this is basically 8.5 volt. Okay, so this is my circuit now, and this is now 1.5 ohm. So now we can also see that here we have two resistors in parallel and one source which is in parallel with my mid resistor here. So in order to find the current here, I can transform this current source into a voltage source, again transforming this one into the voltage source here. Again I can see that the same resistor will be in series with this one, so this it would be 8.5 ohm. The polarity of it will be like this will be plus, this will be minus. So now what will be the value of this voltage source? Again I know that V is equal to IR. The value of I is 1, the value of R is 8.5. So the value of it will be 8.5 volts. Okay, and similarly here, this is the resistor through which I have to find out the current I0. So now this is now a very easy circuit in which I can very easily find out the value of I0, and the value of I0 here will be let me assume the direction of my current like this one. So in order to make this circuit as the at this voltage source as the dominant voltage source, or let me draw it in green. Okay, so let me call it I. So in order to calculate the value of I know that I is equal to the V divided by 8.5 plus 1.5, and the value of V is positive because the voltage here is the rise, because it is entering through here and leaving through here, because I'm supposing the direction of the current is the counterclockwise. So 8.5 divided by this 10, because 8.5 plus 1.5 is 10, so I will get here 0.85 okay amperes. Similarly, I can see here that the direction of I0 is opposite at that of my current I. Let me use a black pen here. So the value of I0 is here minus I, so it would be now minus 0.85 Okay, so that is the current which I have find out by using the source transformation method. These are all the steps which I have followed through this circuit. Okay, so this was my value, and this is the solution of part A. Now in part B of this question, I have to verify the solution or the value of the I naught which I have found out. So in order to solve the solution, in order to solve the circuit now by using the method here, I can use many techniques like the node voltage method or the mesh current method, but I have to deploy the technique which is feasible or which is I think convenient here. So as here we have two meshes in which the branch currents are given, therefore I will use the mesh current method here because I think the technique here will be feasible to find out the output currents here, and from it I can easily find out the current here. So now let me suppose two currents, let me suppose some currents. So here the first current, let me call it the I1, let me call it I2, this is the I3, and this one here is I4. Okay, so now I have these four currents, and I can very easily see that let me solve it here. I can very easily see here that the values of I1 and I4 are already given. So the value of I1 is 2 amps and the value of I4 is how much is this? This is 1 amp. Okay, so this is the 1 ampere current. So the values are already given. So now I have to solve these two loops. Okay, so these two meshes I have to solve. So let me solve them directly. So in order to solve them directly, all the resistors which are connected here are basically the resistor which it shares with the with this loop is basically the 6. So that's why it will be minus 6I1 plus all the resistors here in this loop, its own loop, are basically 6 plus 6 12, 12 plus 5 is 17, 17 plus 17 is 34. So it would be 34I2. Similarly, these resistor it shares with this one is the 17 ohm, so minus 17I3, and similarly the resistor with this one is basically the 5 ohm, so minus 5I4 equal to, and this is the source which it shares with this one. So now the value of this source would be the 34 volts, so that is now 34. So now let me put the values here, the values of I1 and the value of I4. So inputting the value of I4, I will get here a minus 6 multiplied by 2 plus 34I2 minus 17I3 minus 5, and I4 is 1 equal to 34. So by solving then I will get here 34I2 minus 17I3. So this is 12 minus 5 is minus 17, and when minus 17 will be added to the other side of the equation, it will become 51. So let me call it equation number 1. Okay, so this is my equation number 1. Now let us find the same equation for this loop. As we can see here that in this loop only we have the two currents I2 and I3, because this only 17 ohm resistor is the resistance which is shared by these two loops. So now here let me use this color here. So now where minus 17 minus 17 I2 and plus 17 plus 1.5 is 18.5 I3, and the value of this is basically the this is the voltage source, and the value of the current is basically entering through the positive and leaving through the negative terminal. That's why it is the voltage drop. So it would be minus 34. So let me call it equation number 2. Okay, so now we have two equations. So here we have these two equations. So in order to solve them, let me use here the substitution method, in which first I will multiply equation number 2 with 2, and then adding 1 and 2 together. What I will get here, what I will do here, I will add the product of 2, equation number 2 with 2, and then adding with equation number 1. What I will get here, it will be, let me move down further, it will be 34 I2 minus 17 I3 equal to the 51. Similarly, multiplying the equation number 2 with 2 here, I will get minus 34 I2 plus 20 I3 equal to minus 68. Okay, so now adding them together, these two will cancel out here. What I will get, no, sorry, this is 18.5 multiplied by 2, so that would be the 37, sorry. Okay, so now here I will get 20 I3. Similarly, from here I will get minus 17, and from this I3 will be equal to the minus 17 divided by 20, which will give me minus 0.85. So that is the value of I3. Similarly, this is 0.85 amps. Similarly, in this circuit we can very easily see that the direction of the I0 and I3 is basically same, and the same branch current is flowing is the I3. So that's why the value of I0 is equal to the I3, and the value of it is minus 0.85. So that is the current, and we have recently seen in our source transformation method that the value of I was 0.85, and the value of I0 was minus 0.85. So the same has been verified by the mesh current method, and we have found out that our method was correct, and we have found the correct value. So that's it for today, and in this question we have again saw the validity of the source transformation method. I will solve more question in the upcoming videos. Till then, thank you so much and take care of yourself.